Hey guys, Mr. Gardner here again. This time I'm coming at you with a quick lesson about one-step equations. I just want to refresh us on a few things before we get started here. So let's just remember, if we're talking about an equation, here we have an equal sign. We have an expression here, x plus 3. It equals 10, so we're saying that this expression here is equivalent to 10. If we remember, this is our variable. It has a coefficient of 1, but we don't have to put it because of identity property. We have our operation, which is addition, and we are adding onto it this term, which is a positive 3. Okay, so those are just some of the vocabulary we want to use when we're looking at these to get started. So if we remember correctly, if we're talking about a variable being added to and equal to something, if we want to get this variable by itself, which is what we want to do in one-step equations, then we're going to want to subtract this 3 from this side of the equation. Now, like the balance, like a scale, if we do it on one side, we have to do it on the other side to keep it even. If you remember, the equal sign is like the middle of our scale. It's going to hold the balance for us. So if I take away 3 here, I'm going to take away 3 here. Okay, and I'm going to bring my x down, so I get x equals 3 minus 3 is just 0. So I don't have to put that, I can just put x equals, and 10 minus 3 is 7. Now I can see that in this equation, x is equal to 7. So if I wanted to check it, then I just plug this 7 in for x. So instead of writing x plus 3, I'm going to write 7 plus 3 equals 10. And I know 7 plus 3 is 10, which equals 10. And that is a true statement, so I can check and see that 7 is the correct answer. Okay, so let's take a look over here at what it would look like if we had subtraction. It's very similar. Let's say we had x minus 3 equals 10. Okay, so now we have x, and we're subtracting 3 from it, and we're equaling 10. So this expression has to equal this. And again, we want to get this by itself, so I need to get rid of this minus 3. So to get rid of a negative 3, we add 3. Okay, we just do the opposite of what's happening. So again, this is going to become 0, so I'm left with just x on this side. And over here I've got 10 plus 3, and 10 plus 3 is 13. So I get x is equal to 13. Again, let's check. 13 minus 3 equals 10. If I subtract 3 from 13, I get 10 equal to 10. And that checks out, so I'm good there. All right, and it's not much different if we get into multiplication. Let's say we have 3 times x equals 9. Okay, again, we're looking here, we've got this expression, 3 times x equals 9, so this expression has to equal this side. Again, I have 3 multiplying against the x, so I'm going to do the opposite. I'm going to divide by 3, and I'm going to divide this side by 3. Again, this doesn't become 0, it becomes 1, but it's the same thing. If I multiply anything by 1, it's just itself, so I don't need to write 1x. And this side I divide by 3, so I have 9 divided by 3, and that's also going to be 3. Again, we always want to be checking our answers to make sure it works and it makes sense. So 3 times 3, see here, instead of writing x, I just wrote in my result of 3 equals 9. I do these, 3 times 3 is 9 equals 9. So that checks out as well, so that's good. Now where it gets a little bit trickier is when we have division in the problem. So let's say we have x divided by 3. And that equals, let's just say 9, okay, just for continuity's sake. We're looking at this again. If it's a fraction, fractions mean division. I've got the variable being divided by 3 is equal to 9. So a way to think about that is something divided by 3 equals 9. So logically you can think about that as I have to multiply 3 times 9 to get this result. Because if I think about division problem, right, you do division, you get the result, you multiply the result by what you divided by. If it comes out equivalent, then you know you did your division right. So in this case, we're going to times it by 3, and I'm going to times this by 3. Now what really happens here is this becomes x over 3 times 3 over 1, right? Because we can write any whole number as a fraction by just putting it over 1. Equals 9 times 3. So again, I just multiply straight across, and I get 3x over 3 equals 27. And I know if I have 3 over 3, that's really just 1. So really what I have is x equals 27, because 3 over 3 is just equivalent to 1. Again, we want to check this. So let's check 27 over 9. Sorry, 27 over 3. Let's just fix that. A little happy accident there. Equals 9. We know that 3 goes into 27 9 times. 9 equals 9, and that gives us our check. So that's really nice. So those are your basic operations when you're looking at